we've spent the last few lectures looking at significant figures, and we've said earlier that the number of significant figures is a measure of the precision of the number. So the more significant figures we have, the more precise we know something. So now we're actually going to get to the point where we're going to use this information. So let's start by looking at adding and subtracting. And so when you add and subtract numbers, then it turns out the worst number determines the final value. So how do we do something like this? Perhaps we have some measurements. So in the lab, we measure something to be, say, 4.802 grams. And we use another balance and we get a weight of 7.19 grams. And yet another balance gives us a weight of the third object of 8.3042 grams, let's say. And we add these three masses together. Our calculator, of course, will just give us a number. So if we punch these in, we'll get 20.2962, and our calculator, of course, won't give us units, so we've got to put those in. But the rules that we use when adding and subtracting say we go by the worst number of decimal places as our initial results have. So the top result right here, so 4.802, has 3 digits after the decimal place. The second one has 2 digits after the decimal place, and the last one has 4 digits after the decimal place. So that sort of implies that, this one here is good to the thousandth of a gram, this one here is good to 100th of a gram, and this one here is good to 1/10,000th of a gram. So this one here is our worst one, and our worst one limits our final answer. So if our worst measurement is only good to 100th of a gram, even though we measure to 1,000th and a 10th of a thousandth in here and here respectively, that really doesn't help us because this one here limits the precision of our final answer. So we really can't go past this second digit. So we can say that this here should only have 2 decimal places. So we have to round. So 20.29. Okay, now we are eliminating a 6 here. And the rules of rounding basically say whenever you remove a number that is a 5, a 6, a 7, or 8, or a 9, then you round up the number that remains by 1. So the 9, if you like, would round up to a 10. And of course, we don't write a 10 there. We can only write a single digit. So that would mean that the final number is 20.30 grams. So this has 2 decimal places. Now, a lot of these questions will occasionally ask you to figure out the number of significant figures at the end of the day. And it sort of tricks people sometimes because when you add and subtract, you don't pay attention to the number of significant figures, but the final number does have a specified value of significant figures. So although it has 2 decimal places, we can look at this and we can say, well, any digit that's not a 0 is significant. Captive zeros are significant. Zeros to the end are significant if there's a decimal place, which there is. And so that allows us to calculate that we've got 1, 2, 3, 4 significant figures here. So this final value has 4 significant figures.